Good morning, student. I, Om Mohan Saxena, now going to take physics of class 9, and the topic is laws of motion, that is chapter 3. So in this chapter we study about the contact and non-contact forces. First of all, we should know what is the effect of force. The effect of force, that if a force is applied on a body, it can change the state of rest or state of uniform motion along the straight line of a body. Means if the body is at rest, it can be moved only by applying the force, or a body is moving with a constant speed in a particular direction, then that state can be changed by applying the force. Now the next thing, it can change the size or shape of the body by applying the force. What is the force? The force is that physical cause which changes or tends to change their size or the shape or the state of rest or uniform motion along the straight line. Now the kinds of forces, there are two kinds of forces discussed over here, that is the contact forces and non-contact forces. So first of all, we will discuss about the contact forces. These are the forces which are applied on the bodies by making the physical contact with the bodies, that is by touching that bodies. These are the contact forces, and examples are, first of all, frictional force. When a body slides or roll over a rough surface, the force start acting. Suppose this is a body placed on the rough surface, and whenever the body starts sliding or moving on the surface, a force acts opposite to the motion. If the body is moving in this direction, then a force acts opposite to the motion, which is called force of friction. It always opposes the motion of the body. This is called frictional force. Now the next one is called the normal reaction. Normal reaction means whenever the body is placed on any surface, then the weight of the body acts downward and the reaction of that surface acts perpendicular to the body. Means suppose if the body is placed on the inclined plane like that, then the weight will act perpendicular downward, but the normal reaction always act perpendicular to the surface on which the body is placed. That is called a normal reaction. So this will act as an action, and this will act as a reactionary force. Now after that, a tension. The tension is the next. Contact force means if the body is suspended from the rigid support by a thread, then the weight of the body again acts in the downward direction, and this weight of the body is balanced by the tension in the thread, which always acts upward or towards the point of contact. So when the body is suspended by the string attached to the rigid support, the body, due to its weight, pulls the string in the downward direction, and the tension in the string acts in the upward direction. So that is always away from the body and towards the point where the body is tied. It is represented by T. Now the force exerted by the spring, that is called the restoring force. Now if suppose there is a spring tied with the body in the normal state. Now when we pull the spring away or pull the block away in this direction, and suppose now the next condition is that, see, this is the extended position of the spring. Now if we leave the spring at this position, then the spring automatically comes towards the initial position. Why it comes? When we are not applying any force. So when we remove the external force, then what happens? As we move the body away from its mean position, a force acts towards the mean position, which tries to bring the object back towards its original position, and that is known as a restoring force. Restoring force. So that force tries to restore the original position of the body. That is why it is known as a restoring force, and it always acts towards the mean position or towards the initial position. Now suppose the body is in the state of compression like that. So in this case, the restoring force will act in this direction, means always acts towards the mean position. This is the mean position of the body. So when the body is in this direction, or then the restoring force acts towards the mean position like that, and when the body is in the compressed state, again the restoring force acts in this direction, means toward the mean position. So and that restoring force is always directly proportional to the displacement of the body from the mean position. And that too with a negative sign, because the force, restoring force, acts in this direction and displacement is measured in this direction, and that's why the force always directly proportional to the displacement, means as we increase the distance or the displacement of the body from the mean position, the value of restoring force keeps on increasing. Now the next is the force exerted during the collision, means whenever the two bodies collide, suppose they are moving with along the straight line, suppose these are the two bodies which are moving, suppose this is moving with the velocity u and this is moving with the velocity v, and suppose u is greater than v, this is one of the case when their body collides, or both are moving towards each other. So these are the two cases when the bodies collide each other. When the body collide, then this is body number 1, this is body number 2. So this body will exert force on this and this body will exert force on this. So that is called F12. This is the force exerted on body number 1 due to the body number 2. This is equal to the force exerted on body number 2 due to the body number 1. So this is the F21 and this is the F12. The magnitude of both the forces are same, but their direction are opposite, and that's why these are known as action and reaction forces. Whatever be the, means suppose if we place any body on the surface, then this weight is known as the action force, and the reaction of the body or the surface on which the body is placed, that is known as a reactionary force. Now after that, non-contact forces. So what are the non-contact forces? The forces experienced by the body even without being physically touched, they are called non-contact forces. Means when the bodies are not touched, and even then the force acts on that, like a gravitational force, like the magnetic force. These are all the non-contact forces, means the force acting without the contact with the body. So first of all, the example is a gravitational force. In universe, each particle attracts the other particle due to its mass. Means in universe, every body which are having mass, they has capacity to attract the other body, and these are called the gravitational force. Like Earth has the gravitational force, this capacity to attract the other body, means suppose these are the two bodies which are placed on the surface, so they are having the masses m1 and m2. So they are having capacity to attract each other with a certain force, and if the distance between the bodies are r, then we can say that this force of attraction is directly proportional to the product of masses of the two bodies and inversely proportional to the square of the distance between the two bodies. When we combine these two conditions, then we will get m1 m2 upon r square, or it is g m1 m2 upon r square. So this g is known as a universal gravitational constant, and this force of attraction, the force of gravity, that is always attractive in nature. So the bodies which are having masses, they attract each other with a certain force, and that magnitude of that force is directly proportional to the product of the masses and inversely proportional to the square of the distance between the bodies. So these are known as a gravitational force of attraction. Now similarly, if a body is placed on the surface of Earth, or the Earth is placed over here, body is here, then the Earth attracts every body towards its center. Why? Because of huge mass, it attracts the body towards its center, and that force is called the force of gravity. And one more thing, the acceleration with which the body is falling towards Earth, that is known as the acceleration due to gravity, represented by small g, and the value is 9.8 meter per second is square. So here we are discussing about the gravitational force. So this is the formula for the gravitational force, and the bodies, any bodies, not only Earth, any body which are having the mass, that can attract the other body. Now one question arises over here in your mind, ki suppose if the two bodies are placed on the surface of Earth, they are having masses, so if they are attracting they should move towards each other, why they are not moving towards each other when they are attracting each other? So the answer is that because they are placed on the earth, and earth is a very huge body, so they are attracted towards the center of earth with a certain force, and this force is very much higher, very much stronger than these forces, and that's why the body cannot move, because they are attracted towards the center of earth. This is the reason for that. Now the next one is the electrostatic force, the force of attraction between the unlike charges. There are two kinds of charges. One is called the positive charge, another is called negative charge. So I think positive and negative charges, if I discuss a little bit about the charges, means any body which are having, all the bodies are made up of the atoms, and the electrons are revolving around the nucleus in these atoms. The atom which are having electron at the outermost orbit, these electron is least attracted towards the nucleus because it's very far from the nucleus in comparison to the inner orbits. So whenever this electron gets energy, it leaves the orbit and it becomes free. So these are called the free electrons, right? So whenever a body loses the electron, it acquires the positive charge, and the body who acquire or who takes the electron gets the negative charge. So in this way the charges are divided in two categories, positive and negative charges. So it is observed that if the two like charges, means two positive charges or two negative charges are placed, they always repel each other. And two unlike charges, positive and negative, they always attract each other. And there is also one law, like just we have read about the gravitational law of Newton, that was F is equal to m1 m2 upon r squared. Similarly, there is a Coulomb's law of electrostatics, and that is exactly identical with that, and that is given by F is equal to k q1 q2 upon r squared, where q1 and q2 are the two charges separated by a distance r. Then this is the formula for that force between the two charges, and in this case the force may be attractive as well as repulsive also. So whenever the two charges are same nature, they repel, and when they are opposite nature, they attract, and that is known as the electrostatic force. And these are non-contact force because at a certain distance they attract or repel each other. After that, the magnetic force, the force of attraction or repulsion between the two magnetic poles are called the magnetic force. Now in the case of magnet, what happens when there is a magnet? So one end is a north pole, another is a south pole, and we cannot break. If we break the magnet, then again a north and south poles are created. So always when there are similar poles, like the charges, if the poles are same, that is, suppose north is here and north is here, so they will repel. Similarly, when south is here and south is here, again they repel, and when north is here and south is here, they attract. So like poles repel, but unlike poles attract each other. So there are general character of the non-contact forces. What are the general character? First one is that the gravitational force is always attractive in nature, while the electrostatic force and the magnetic force may be attractive and may be repulsive according to the nature of the charges and the nature of the magnets, whether this is a similar or poles or opposite poles, or the similar charges or opposite charges. Secondly, the magnitude of non-contact forces, that's I have given over there. There are two formula I have given. One for the gravitational force, in which we have written as F is directly proportional to m1 m2 upon r square. Similarly, in the case of electrostatic forces, that is q1 q2 upon r square. Now in both the cases, you can see that the force is inversely proportional to the square of the distance between the two charges or two bodies. So the magnitude of non-contact force decreases with the increase in separation. As we increase the value of r, the value of F keeps on decreasing. So the magnitude of non-contact forces decreases with the increase in the separation between the two bodies, and this force is inversely proportional to square of the distance between the two bodies. So this is the nature, means contact on non-contact forces. Thank you. Have a good day.